talk about our molecular formulas. Some people might have attempted number 1 on the assignment, choosing between molecular and empirical. And so today we're actually going to learn how to actually tell them apart. Okay? So molecular formula is when they're not completely reduced down. Here we go. So to tell the difference between molecular and empirical, okay? These are all molecular formulas. If you notice, the subscripts can all be divisible by something. Okay, so like for example, what can we divide C2H2 by? 2. So just to see a comparison, if this is a molecular line, then empirical, if we divided our subscripts by 2, what would the empirical formula be? CH. We just have one of each. Okay. C6H12O6. Does anybody know what that is?
That's sugar.
It's glucose. Yeah, it's glucose. So if we would divide that, what would we divide it by? 6. So what would our CH2O? And then last but not least, we have P4O10. What can we divide those by? 2. We can't divide by 4 because 4 doesn't go into 10 very well. So our empirical for this one would be P2O5. Okay? So molecular, they can be reduced. Okay? Because they can be reduced, this is the equation that we're going to need for our examples. Okay? How we figure out, like, you know how we divided by 2, divided by 6, divided by 2 again? That number, what we would divide by, or in another case, if we start with the empirical that we can multiply by, we can find out from the molar masses. Okay? So what you do is you take the molar mass, MM stands for molar mass, of the molecular formula over the molar mass of the empirical formula. And by doing that ratio, that will give you the number that you would have to multiply by to get your empirical or your molecular formula. Okay? So we're going to be doing things today with molar masses so that we can find out this number, so that we can identify what the molecular formula is. Okay? So we have 2 examples, and like the first example is like number 4, and example the last example is like number 5 on the homework. Okay? So here we go. Maybe. Thank you. Okay. So in example 20, we want to find the molecular formula. So MF stands for molecular formula. That's what we're trying to find. Of a compound whose molar mass is 60.0 grams per mole, and empirical formula is CH4N. Okay, so a hint. You might want to make notes for yourself. Whenever you have a molar mass in the problem, that's the molar mass of the molecular formula. Okay? So I'm going to label that as MM of the molecular formula. So we're going to plug that in on top. Okay? In this case, we are given the empirical formula. So that means in order to plug into our ratio, we need to solve for the molar mass of the empirical formula. Okay? So let's do that. So can anybody look at a periodic table? What is carbon number? 12.001. 011. Thank you. Plus, we have 4 hydrogens. So we're going to take 4 times hydrogen. And that's 1.0079. Okay. Plus, and then nitrogen, 14.007. Okay. So then, our molar mass of the empirical formula is, so I'm going to get 30.0496. Okay. So now we're going to take the molar mass of molecular over molar mass of empirical. Another way, if you don't remember which one goes on top, you always put the bigger number on top. The larger molar mass goes on top. And that's so that you get a bigger than 1 number when you're done. Okay, so we have 60.0 over our molar mass we just found, 30.04. So what's that going to equal? 1.996. So can we round to whole? 1996, 1997. What does it round whole to? 2. That's what really matters. It rounds to 2. Okay? So that means that this 2 is what we're going to multiply the subscripts by in the empirical formula to then get our molecular. Okay? So sometimes I show it like this. You don't have to show it like this. If you can just do it without showing the work, that's fine. But I put my empirical inside parentheses. And then we know that, like, when finding the molar mass, the 2 distributes through. So let's write molecular formula by distributing our 2. So how many C's do we have now?
2.
We have 2 C's, then how many H's? 8. And how many N's? And 2. So this would be your final answer. Okay? And again, if you were looking at these 2, this one's reduced, and this one is not reduced. Reduced is empirical, not reduced molecular. Okay? So that's like number 4 on the homework assignment. Number 5, you're given percents. So let's do example 21, where we're given percentages too. Okay? What are we going to have to do with those percentages? Because we're not given an empirical formula this time. Okay, here we go, example 21. So we want to find the molecular formula, so we're still going to do the same steps as last time, but we are given percentages. So if we're given percentages, what do we need to do? We got to do our 4 steps from yesterday to find the empirical. We have to first find the empirical before we can move on to molecular. Okay? So how many elements do we have?
3.
We have carbon, 6.7% of hydrogen, and 53.3% oxygen. So that's 3. So I like to make my little list down the side. Okay. What's our first step to find empirical? What do we do? Percent to mass. What's that mean? Change your percent sign to the gram sign. Make sure you put it over 1 so we know we're doing our dimensional analysis. Okay, so we have 40.0 grams of carbon, then we have 6.7 grams of hydrogen, and 53.3% grams of oxygen. So step 1, checked off. Step 2 says mass to moles. So how do we get from mass to moles yesterday? We're going to divide by our molar mass. That's right. So 1 mole will go on top, and then the molar mass of the element will go on bottom. So carbon, 12.011. Hydrogen, 1.0079. And oxygen, 15.999. So can we divide and conquer, and somebody tell me what you get for each of these? 3.33? Okay.
Hydrogen is 6.65.
6.65. All right. And oxygen, anybody find that? 3.33. Okay, thank you. So step 2, taken care of. Step 3, divide by smallest. What's our smallest in this case? 3.33, which is nice because both carbon and oxygen will be just 1. And then what will our hydrogen be?
1.2.
It rounds to be exactly about 2. Yep. Okay. So at this point, our empirical formula would be what? What would you write down in your paper? CH2O. Yes. what should we do next? What's the next step? Are you already there? Do you already know what to do? Okay, we need to find our molar mass of the empirical. Because remember, this molar mass right here, what's this molar mass of? The 89.90 is the molar mass of the molecular. I forgot to label that. So that means we need to find the molar mass of the empirical to do the rest of our problem. Okay, so to find the molar mass of the empirical formula, we take 1 carbon plus 2 hydrogens plus 1 oxygen. And did somebody solve that already?
30.0258.
Did you get 30? That's the most important part. Use your number and we'll use ours up here. It's fine. Of the empirical formula we just solved for was 30.0258. Okay. So, this molar mass in the words of the problem is our molar mass of the molecular. So does that go on top or on bottom when we're trying to find a ratio? The bigger number goes on top. So we're going to have 89.90 over our empirical formula. And did anybody already divide that out? What did you get? About 3. It would round to the whole number 3. So then, our molecular formula.
Hopefully this will be the final interruption, but we're testing one more time. Test, test.
You got an A+.
So our molecular formula is Alright, so we need to finish 4, 5, and 1 on the empirical molecular formula practice. I have the answer key up here.